Hello, children. Let me know if you can hear me. You can text me in the chat box. If my voice is clear, then I can start taking the class. Thank you, Simba. Okay, so let's wait for one minute till the students join. We'll be doing LC oscillations today. So I want everyone to just uh, hit thumbs up in the chat session so I can understand that all of you are observing the class clearly. And also if everything is visible to you. So is everything clear? There is no answer. No, Shin. Okay, right. Okay, thank you. Fine, so we can begin, right? So in LC oscillations, we take an inductor and a capacitor and connect them in this manner. So first of all, before I could start, let me explain few things about what an inductor does. We know that inductor L is a device which stores magnetic energy. It stores magnetic energy. Magnetic energy is stored by inductor. Whereas if you take capacitor and it stores electrical energy. It stores electrical energy. So we've studied about two types of circuits already in the session, in the class, that is one is RC circuit where you have a resistor and a capacitor which we charge using a battery. So when it reaches steady state, this is a capacitor and this is potential difference. So when it reaches steady state, what happens is basically the capacitor is fully charged like this. So this is a capacitor which is fully charged and no current will flow through the battery because the potential difference across the battery and the capacitor remains is same. So therefore the current will stop in steady state, but it will charge. So we wrote the charge across the capacitor is Q is equal to Q naught into 1 minus e power minus t by RC, which is the charging of a capacitor. Whereas if you take an inductor and connect it to a resistor and then a battery, then uh, the inductor first will oppose, but however after a very long time there is no opposition from the inductor and current generally flows through the resistor, and the inductor stores magnetic energy like this. So this is the magnetic energy stored by inductor in the form of magnetic field. So the magnetic energy stored by inductor in the form of magnetic field is a half Li square. Half Li square is the magnetic energy stored in inductor. And we know that the capacitor stores electrical energy. We call it as UE, which is half CV square. This half CV square can also be written as Q square by 2C, which is the energy stored in the form of electric field. So we have studied this capacitor and inductor separately. Ye wala. This one and this one we have studied separately. Right? Right. So capacitor stores electrical energy and inductor stores magnetic energy. Now what happens is, if you take this situation where there is a capacitor and an inductor, and now what I do here is, observe this point, what I do here is I take an inductor, we know that inductor stores magnetic energy whenever current passes through it. So I connect it to a capacitor like this, and I charge the capacitor. So the capacitor is fully charged. So the capacitor is fully charged now. Okay, right. So when a fully charged capacitor is connected to an inductor L, and this is C, and let's say there is a switch here, and I close the switch. The moment I close the switch, the capacitor gets discharged. So the capacitor, what is happening to the capacitor? It is getting discharged like this. It is getting discharged like this. This is how it gets discharged. So this is discharging of the capacitor. So, but what happens is when it discharges, there is no energy lost actually, because there is no resistor. We have studied that here when a capacitor, see, suppose I take a capacitor which is fully charged, okay, fully charged capacitor. I take a capacitor and I connect it to a resistor, let's say. So when I close the switch, the entire energy is lost as heat, dissipated as heat, right? Dissipated as heat. So when you connect a fully charged capacitor to a resistor, energy is lost as heat. Energy is lost as heat. And also this one, when you take an inductor which is already storing magnetic energy and you connect it to a resistor, we are talking about decay of current, and here we are talking about in this we are talking about discharging of a capacitor. So here inductor, it is already storing some magnetic energy, but when you connect it to resistor, it is lost as heat. Here also lost as heat. So when you have a resistor, it is obvious that heat is lost. So you take a fully charged capacitor and an inductor, connect both of them, then heat is lost. But whereas in this case LC oscillation जो हम शुरू करने वाले हैं अभी, whereas in this case what happens, it is different, because there is no concept of lost, because you're connecting a capacitor which stores electrical energy, and when it is discharging like this, let me show you. When it is discharging like this, the pointer, okay, when it's discharging like this, when it is discharging, there is a current and there is a magnetic energy, but this positive charge entirely comes here and stores here in the negative. So again the situation turns out in something like this. So you have an inductor and a capacitor, and finally this situation is going to become like this. So this is plus plus and this is minus and minus. You understand that? Right. So here again this was electrical energy before. Now when it was discharging, some part is converted into magnetic energy. Here this is electrical energy. When it is discharging like this, some part is converted into magnetic energy, and again when it is charging. So this is a concept of charging and discharging. So what is happening here is capacitor the positive charge on the capacitor is combining like this here. So it is capacitor gets discharged, so it is converted into magnetic energy. Now when this positive charge turns out and comes here, what happens? This completely positive comes here, and again you have electrical energy. Now again this will come here. So this is oscillation of charge on the capacitor. तो positives इधर से इधर आ रहा, फिर इधर से इधर जा रहा, इधर से इधर आ रहा, इधर से इधर. So in that manner what is happening? The charge is oscillating and hence energy is also oscillating. ये जो इंट्रोडक्शन में अब तक दिया, ये समझ में आया क्या? लेट मी नो. हम लोग अभी एलसी ऑसिलेशन शुरू नहीं करे. आई वाज जस्ट गिविंग यू द इंट्रोडक्शन दैट दिस रेसिस्टर, whenever current passes through resistor, वो चले गया, मतलब heat is lost. Whenever current passes through resistor, heat is lost. In this case of LR and also in this case of CR. Now LC oscillation is slightly different. Here there is no loss, right? So we'll see what happens here, right? So first of all, I'll take an inductor and a capacitor and of course a switch, right? So this is inductor L and capacitor C. Now the capacitor is fully charged. The charge on the capacitor is fully charged. So this is minus, minus and minus, minus, okay? So I apply loop law. So when I apply loop law, I know that at t is equal to 0, the capacitor is already fully charged. So q is equal to q naught. Q naught is the charge on the plates of the capacitor. So apply loop law. So this is discharging. So current ऐसा supply हो रहा. This is the current. तो current ऐसा जा रहा, right? So when I apply loop law here across the inductor, it is minus L di by dt. Current is increasing, and negative to positive gain q by c is equal to 0. So at t equal to 0, q is q naught. At t equal to t, some charge is lost, so the charge, let's say q is equal to q. Now q is equal to, if I solve this one, q by c is, so q is equal to LC into di by dt. Okay. Is it looking like this one? Can I write this as a di by dt is equal to 1 by LC times of q? Right. So di by dt can also be written as d square q by dt square, because I know that current is the rate of flow of charge. So current is dq by dt हम लोग लिख सकते. So I can write current is equal to dq by dt. So उसको फिर से if I differentiate on both sides, then I have di by dt is equal to, again this is double derivative of the charge d square q by dt square, is equal to 1 by LC into q. So if you observe this one, is it not looking like the acceleration A is equal to omega square x? Because here also in SHM, what we do in SHM, the acceleration is A is equal to omega square x. A is equal to omega minus, of course, but minus is giving you that it always tries to come back. So A is equal to omega square x. I am taking the modulus of that. Here also modulus of that. So x is displacement. If you double differentiate this one, then you are going to get acceleration. So ये भी same है ना. तो here also you have q and q. That means if you differentiate q twice, then you are going to get this one, right? You follow till here. So A is equal to omega square x के form में. So this is SHM. This is condition for SHM, which is in first year. So in here also this is SHM. But what is simple harmonic motion here? But what is executing SHM here? X is executing SHM. यहाँ पे जो है x is executing SHM, and this is the double derivative of x. Here also q is executing SHM, and this is double derivative of q. So इसका differential equation solve मैं अभी नहीं करूँगा. Direct I'll write the solution of that, and the solution of that is q is equal to q naught cos omega t. Is the charge. इसको solve करने के बाद मतलब ये this is expression 1. So when you solve that expression 1, you're going to get this one. Okay, this is not required how to solve that. We can discuss it later. But right now it is easy to understand, sir, because when you put, sir, how you got omega t, where omega square is compared with 1 by LC, then omega is 1 by root LC. Okay, and also you can write omega is 1 by root LC. Then omega also you can write omega as 2 pi by t, that is equal to 1 by root LC. Then the time period is t is equal to 2 pi root LC. Clear? So this is the time period. Sorry for that. That was from my child's school. यहाँ तक ठीक है ना बच्चों? तो अब क्या होने वाला है देखो. Q is equal to Q naught cos omega t. That is a charge at any instant on the capacitor. So now we'll observe what happens. So we'll see Q is equal to Q naught. I am writing it this way. Q naught cos of omega can be written as 2 pi by capital T into small t, right? Yeah, so Q is equal to Q naught into cos of 2 pi by capital T into small t is the charge. This is यहाँ पे लिख देता हूँ. This is a charge on capacitor at any instant. Okay, right. So the charge on capacitor at any instant is this one. So you have the capacitor at situation t equal to 0. I have to draw many diagrams here, so observe carefully. So this is inductor L and this is a capacitor C. Both easy है यहाँ से. So capacitor C. So yeah. So this is completely charged like this. Plus plus minus minus लिख दिया मैंने. So at t equal to 0, I can say Q is equal to Q naught cos omega t. तो omega t में अगर 0 रखे तो Q is equal to Q naught, right? So what is the electrical energy stored in the capacitor? Q naught square by 2C. And there is no magnetic energy which is stored in the capacitor, which is stored in the inductor. But what happens if I draw this diagram? Again here I am changing it, see. Here. Now this is the instant at t is equal to t by 8, let's say. T by 8. T is equal to t by 8. So t is equal to t by 8, I want to substitute here. In q is equal to q naught cos 2 pi by t इसमें है ना, इसमें substitute करना है. So when I substitute t is equal to t by 8, in q is equal to q naught cos of omega is 2 pi by capital T into t small t की जगह t by 8. In place of small t I am writing it as t by 8. Okay, t by 8. What happens if I do that? Q is equal to q naught into t got cancelled, 2 also get pi by 4. Pi by 4. Cos pi by 4 is 1 by root 2. So the charge becomes q naught by root 2. And we know the value of q naught by root 2 is 0.707 q naught. Right? तो मतलब charge कम हो गया. What about electrical energy stored in the capacitor? Is it q square by 2c? So in place of q I have to write q naught by root 2. So if I do that, it becomes q naught square by 4c, which I am writing as 2c into half. तो मतलब let's say this is the initial electrical energy. Okay, now it has become half. So when electrical energy become half, okay, when half of q naught square by 2c, that means the remaining energy is converted into magnetic energy, right? यहाँ electrical energy जब half हो गया तो remaining energy is converted into magnetic energy. So I can say magnetic energy is also the same, because sum of the total energy should always remain constant. So here total energy is total energy at instant t equal to 0 is sum of electrical energy and magnetic energy. If I add these two, what do I get? If I add these two, I will get q naught square by 2c plus 0, which is q naught square by 2c. And also at this instant, at t is equal to t by 8, at this instant, the total energy should also same. तो मैं क्या बोलूँ, इलेक्ट्रिकल एनर्जी अभी हाफ हो गई, तो वो जो बच गई हाफ वो मैग्नेटिक एनर्जी में स्टोर हो जाती है ना. सो हियर एनर्जी इज ऑल्सो ऑसिलेटिंग, एनर्जी भी क्या हो रही, हाफ हो जा रही. सो एट t इक्वल टू 8, so energy is half. Now if I observe at t is equal to t by 4, you will see what happens. T equal to t by 4. At t equal to t by 4, if I substitute that in this one, q is equal to q naught cos of 2 pi by capital T into t by 4. So 2 got cancelled, pi by 2, and cos pi by 2 is 0. So there is no charge, correct? There is no charge, that means electrical energy stored is completely 0. Then what about magnetic energy? Should it be completely q naught square by 2c? I know that magnetic energy का form ये नहीं है, half Li square है. But still, this is the value of the energy which was oscillating. This is the value of the energy. This is the value of the energy which was oscillating from the beginning. From the beginning. So in the beginning, समझो ये सब 100 है, इसकी वैल्यू 100 है, ये 0 है, तो अभी नेक्स्ट क्या हुआ, ये 50 हो गया, ये 50 हो गया, फिर इसके बाद ये 0 है, ये 100 हो गया. Following it? Let me know if you are following it. I have to see that comments, otherwise I don't understand. Late bird, okay. But the reply is early. Fine. Now, all of you, you tell me. So, at T is equal to T by 4, there is no electrical energy. There is only magnetic energy. Now, you tell me what happens at next time, which is at T is equal to. So, T by 8 बढ़ा लेते जा रहा हूँ मैं. So, first is T by 8, this part. Second is T by 4. Now, we'll add T by 8 to it. 3T by 8. Tell me what happens at 3T by 8. Basically, at T by 4, there is no energy stored in the capacitor. No energy stored in the capacitor. The entire energy is magnetic energy only. Full magnetic energy. Zabardast hai idhar. Full magnetic energy. There is no charge on the capacitor. At T equal to 3T by 8. What happens at T equal to 3T by 8? What will be the charge on the plates of capacitor? Q is equal to Q naught into, what should I write here? And what will be the situation? आंसर तो आना चाहिए. Very nice. Finally, the answer from the late bird. Okay. Who is this late bird? Okay. 3T by 8 cos of 2 pi by capital T into 3T by 8. So 3 by 4, 3 pi by 4. Cos of 3 pi by 4 is Q is equal to Q naught minus 1 by root 2. So this is minus Q naught by root 2. Which means here there is positive now and there is negative. You understood that, and still there is half magnetic energy. Half magnetic energy is there. So here electrical energy and magnetic energy are same, that are equal to Q naught square by 4C. I hope you understood this. आधा है ना, दोनों भी आधे आधे equal है. And what happens at T is equal to 4T by 8, which is T by 2. So at T by 2, then you have Q is equal to Q naught into cos of 2 pi by capital T into T by 2. Cos 180 minus 1. So Q is equal to minus Q naught. Then the electrical energy stored is again Q naught square by 2C. Square करे तो वही आता है. And magnetic energy is 0. Which means this is the situation. LC. So now the entire charge has come here. This is plus plus plus. So now there is no magnetic energy, completely electrical energy as electric field between the plates. So if you observe what happened in this duration from t equal to 0, t equal to 0 पे आपके पास full electric field है, magnetic field नहीं है, magnetic field 0. There was only electric field not equal to 0. As you move up, there are both electric field भी है and magnetic field भी है, and they are same. Okay. So you observe this one, which I have explained in the beginning. So here what happened, if you observe it, see, LC oscillation में सर क्या करना है? LC oscillation बहुत simple है. LC oscillation says that if you have this is first of all, this is the charge on the plates of capacitor at any instant. At any instant, the charge on the plates of capacitor. Okay. So Q is equal to Q naught cos omega t. So it can be also written in this way. Sir, kaisa hai sir? Because when I compared the Kirchhoff law, when I apply Kirchhoff law for this one, and when I applied Kirchhoff law for this one, I got this equation. I compared it with SHM. Then I concluded that the charge on the plates of capacitors Q is equal to Q naught cos omega t. So which I have written in this way, where capital T is a time period, which can also be written as T equal to 2 pi root LC. Okay. Right. So at T equal to 0, so at T equal to 0, what happened? There is full electrical energy, no magnetic energy. At T equal to T by 8, half half हो गए इन लोग. T equal to T by 4, अब क्या हो गया? ये इलेक्ट्रिकल एनर्जी जीरो हो गई, सिर्फ मैग्नेटिक एनर्जी में कन्वर्ट हो गई उन्हें. Again at T equal to 3T by 8, half half. And at T equal to T by 2, now the charge which I was saying here, it was plus before here, and now it completely came here and became plus here and minus here. So oscillate हो गया charge. The charge oscillated. So it is only half oscillation of the charge, because charge now it has to go back to the initial situation. ये situation में चले आना है फिर. This situation it has to go to this situation back. So it will occur in the next T by 2 seconds. So have you followed this one so far? Answer the question. If there is any doubt, I'll explain it again. No doubt. Thank you. Thank you very much. So, yeah, that's it. I think it is enough. You just got an idea, so we'll see in tomorrow's class. We'll try to solve some problems. What do you say? If it is okay for you, I'll continue. Alright then, children. See you in tomorrow's class then. उमर इधर आओ. हाय बोलो. हाय. इधर इधर कैमरा में देख. हाय. रिलैक्स बोल. रिलैक्स. ओके चले जाओ. Sir, why did the charge shift? Because it is oscillating. Here, see, if you observe, पहले जो था Q is equal to ये था Q naught था Q naught, which means यहाँ positive था. अब क्या हो गया, Q इज इक्वल टू माइनस क्यू नॉट आ गया, मतलब यहाँ नेगेटिव हो गया। फिर आफ्टर टाइम t/2 सेकेंड्स फिर Q इज इक्वल टू क्यू नॉट हो जाता। सो हाफ टाइम में जो है ये चार्ज इधर चले गया, फिर रिमेनिंग हाफ टाइम में इधर आता, तो ऑसिलेट होता वन टाइम, लेकिन एनर्जी दो बार ऑसिलेट होती। ओके ना? Okay, children. See you in tomorrow's class. Enjoy your holiday. If there is any time you can take out for physics, take it out. Thank you. Bye.